So good afternoon, everyone. I will be taking the next 10 minutes to talk about a user-friendly approach to creating three-dimensional finite element models utilizing point cloud data for structural engineering purposes. And this is a research project supported by the Conservation Directorate and the Digital Documentation Team of Historic Environment Scotland, while it's funded by Edinburgh Napier University. Scotland's historic environment is an essential part of the country's cultural background and its economy. And the country is often referred to as a nation of stone, typified by its historic masonry buildings and castles that form one of the richest legacies of traditional and historic structures in the United Kingdom. So some of these are internationally iconic structures of historical and cultural heritage, and either in remote areas or in the major cities, there are excellent examples showcasing the use of natural building stones as a construction material. Scotland is world famous for its castles, not just because so many are immaculately preserved, but also because many are set against some of the most breathtaking scenery in Britain. So since 2017, the Scottish government has worked with Historic Environment Scotland, which is the lead public body established to investigate, care for and promote Scotland's historic environment, to develop a long-term infrastructure investment plan for restoring, enhancing, and conserving the built heritage. As part of this, their digital documentation team undertook the mission to digitally document every place and object in their care through the RAY project. The development of digital technologies such as terrestrial laser scanning has already helped produce accurate representations of structures with applications in conservation, monitoring, and building information modeling. But the exploitability of laser scanning outputs in the form of point clouds is still challenging with respect to the application for structural analysis of historic buildings. The project seeks to explore the procedural options for the development of numerical models for structural purposes, linking available three-dimensional point cloud data to commercial structural engineering software to enhance analysis options for historic masonry structures in the care of Historic Environment Scotland. So this research was based on a topic of common interest between our university and Historic Environment Scotland, having as a case study a freestanding 6 meters high block of masonry referred to as the Tusk, which is at Spynie Palace at the north of Scotland. So it appears as an isolated pillar and forms the only upstanding remains from a 15th century load-bearing curtain walling that has considerable archaeological significance. It was chosen as an example of a very irregular structure in need of intervention to demonstrate a pilot process for creating a three-dimensional solid mesh compatible with commercial engineering software, while at the same time using simplified material laws and boundary conditions to allow for a first stage structural assessment. Processes necessary to simplify and reconstruct the three-dimensional mesh model from point cloud data were performed, with operations comprising the point set simplification and the cleaning of data and surface reconstruction to create a thin watertight mesh. The open source tool MeshLab was used for the application of appropriate filters to approximate noisy data and produce smooth, robust surfaces with points that are uniformly distributed. The thin mesh was used as the basis for the creation of a three-dimensional solid structure in SolidWorks that constituted input compatible with finite element commercial software, such as Abacus or ANSYS. ANSYS workbench was used in this case, with the resultant model balancing computational cost and accuracy with respect to the needs of this project. Masonry was modeled using a continuum homogenized approach, implicitly considering the effects of mortar joints. And the wall is made of sandstone blocks bonded with lime mortar and arranged in random patterns. So that led to the assumption of a simplified composite material behavior, adopting values of mechanical properties from relevant literature. The wall was considered as fixed at its base, and combinations of self-weight, live load, and wind loads appropriate for that area were considered and applied for evaluating the Tusk's structural performance, the structural response to a range of reasonable loading conditions under static analysis. So given the current condition of the Tusk, results were interpreted by means of macroscopic examination of displacements and a safety factor, considering combinations of stresses based on a Moore-Coulomb failure criterion. Results confirm on-site observations from Historic Environment Scotland that the Tusk shows signs of instability and sways when loaded laterally. With the analysis assumptions considered, the stress combination for failure would be exceeded in large parts of the structure, although examining closely how this develops over the incremental application of the load combination, this does not happen before reaching about 85% of the total design load. The whole project verified the pilot process for using existing point cloud data for structural engineering applications and confirmed the compatibility of numerically observed vulnerable areas with the existing failure patterns. Indeed, critical load combinations lead to stress patterns in accordance with the location of vulnerable areas with visible signs of deterioration on the real structure, exhibited mainly as diagonal cracks and splitting of joints. Having completed this pilot project, areas of further research comprise evaluation of the potential of advanced material laws for masonry, alterations in the mesh generation choices, and consideration of alternative boundary conditions, including the current state of the structure's foundations and existing defects. The project was valued by all partners involved for its larger scale potential to improve structural monitoring strategies and to lead to more targeted interventions as needed. Thank you for your attention, and I'm happy to get any comments or questions if we have the time.
Thank you for your talk. Any questions or comments?
I have a question. Can you give more details on the macrostructural approach that you use in your model?
So the masonry was in a bad condition, so it could not be accurately estimated. So I collected data from the actual material that was used on that structure, although the vulnerability and the weathering conditions could not have been quantified. And then I compared that with guidelines from the literature, as well as the Italian building codes, which were a good source of information. And then the values were approximated, and we took a range of values anyway to be able to have a reasonable estimation of the mechanical properties.